Download this code from codegive.com, link in the description below. OK, let's dive into the world of debugging Prolog code. Prolog's declarative nature can sometimes make debugging different than in imperative languages. We'll cover strategies, tools, and common pitfalls, complete with illustrative examples. Understanding the Prolog paradigm and its impact on debugging. Before we dive into tools, it's essential to grasp how Prolog's fundamental concepts shape the debugging process. Declarative programming. You specify what you want to achieve, not how. This means you're writing rules and facts, and Prolog's inference engine, the resolution process, figures out the execution path. This is both a strength and a challenge for debugging. Unification. Pattern matching is central. Understanding how variables unify, or fail to unify, is crucial to understanding why a goal succeeds or fails. Backtracking. When a goal fails, Prolog backtracks, trying alternative rules or facts. This can lead to unexpected behavior if your code isn't designed carefully. Logic variables. Variables can be unbound, bound to terms, or bound to other variables, creating chains of unification. This dynamic nature needs to be considered during debugging. Cut. The cut operator prunes the search tree, preventing Prolog from backtracking to alternative solutions. It can improve efficiency but can also mask errors if misused. 2. Common debugging strategies. Here's a breakdown of common debugging techniques, followed by examples. 1. Tracing. The primary tool. It allows you to step through the execution of your Prolog program. 2. Spy points. Set breakpoints on specific predicates to examine their behavior when called, succeeded, failed, or redone. 3. Print statements. Strategically insert write/1 and NL/0 calls to display the values of variables or the current state of the program at specific points. This is especially helpful for complex calculations or data structures. 4. Simplify the problem. Reduce the size of the input data or the complexity of the rules to isolate the source of the error. Divide and conquer is a good approach. 5. Test cases. Develop a suite of test cases, queries with known expected results, to verify the correctness of your code. Run these tests after making changes. 6. Commenting out code. Isolate the problem by temporarily disabling parts of your code to see if the error disappears. 7. Visualize the search tree. Mentally or with tools, try to visualize the execution path and how Prolog backtracks. Some advanced tools provide graphical representations of the search tree. 8. Check for common errors. Typographical errors. Prolog is case sensitive. A simple typo can lead to unexpected failures. Incorrect argument order. The order of arguments in a predicate is significant. Unintended cuts. Ensure cuts are placed correctly and are not preventing Prolog from finding valid solutions. Circular definitions. Beware of predicates that call themselves without a proper base case, leading to infinite recursion. Variable scoping. Variables are local to the rule in which they appear, unless explicitly shared. Use of equals versus equals. Equals is for unification, attempting to make two terms equal, while equals is for identity, checking if two terms are already identical. 3. The debugging tool, SWI Prolog. We'll focus on the debugger provided by SWI Prolog, a popular and feature-rich Prolog implementation. The concepts are generally applicable to other Prolog systems as well. Starting the debugger. Trace, enter this at the Prolog prompt. This turns on tracing for the entire program. Nodebug, turns tracing off. Asterisk spy points asterisk. Asterisk spy, predicate underscore name slash URID, dot sets a spy point on the specified predicate. For example, spy, append slash 3, dot. Asterisk na spy, predicate underscore name slash URID, dot removes a spy point. Asterisk na spy all removes all spy points. Asterisk debugger commands asterisk, when the debugger pauses at a spy point or during tracing. Asterisk C, creep step to the next port, call, exit, redo, fail, of the next predicate. Asterisk L, leap step to the next port of the current predicate. This skips over the internals of called predicates. Asterisk S, skip over the execution of the current predicate. You'll see only the exit or fail port. Asterisk O, out continue execution until the current predicate exits. Asterisk N, node bug turns off debugging and continues execution without tracing. Asterisk G, goals displays the current goal stack, the list of goals that Prolog is trying to satisfy. Asterisk P, print prints the current goal and the bindings of its variables. Asterisk, help displays a list of debugger commands. Asterisk A, abort aborts the execution. Asterisk R, retry restarts the current goal from the beginning. 4. Debugging example, a faulty list reversal. Let's examine a broken reverse/2 predicate and debug it using the techniques described above. This seems correct at first glance. Let's test it. It appears to work. But let's modify the reverse_helper rule to introduce an error. Now, let's try the same query. That's not right. Let's debug using trace. Notice that in the reverse_helper calls, the accumulator remains unchanged throughout the process. This is because the buggy version of the code never updates the accumulator with head. Now, let's use a spy point to focus on reverse_helper. By stepping through the reverse_helper calls, you can observe that the second argument, the accumulator, is always. This confirms our suspicion that the accumulator is not being updated correctly. This will help you locate where you have made the error in your code. V. Print statements for debugging, aka printf debugging. Sometimes, you need more control than the debugger provides. Insert write/1 and nl/0, new line, calls to display variable values or track program flow. When you run this with reverse, 1, 2, 3, result, dot, you'll get output like. This allows you to trace the execution flow and variable values without the interactive debugger. Remember to remove the write/nl statements once you've fixed the bug. 6. Advanced debugging techniques. Asterisk conditional breakpoints, SWI Prolog. You can add conditions to spy points so the debugger only pauses when a specific condition is met. This is useful for complex predicates, where condition is a Prolog goal that must be true for the debugger to pause. For example, asterisk graphical debuggers asterisk some Prolog environments offer graphical debuggers that visualize the search tree and variable bindings. These can be helpful for understanding complex backtracking scenarios. Consult the documentation for your specific Prolog environment. 7. Common Prolog debugging pitfalls. Asterisk cut placement asterisk incorrectly placed cuts can prevent Prolog from finding solutions. Double check that your cuts are only pruning redundant search paths, not valid solutions. Asterisk instantiation errors asterisk these occur when a predicate expects a variable to be bound to a value, but it's still unbound. Make sure your predicates have sufficient instantiation checks. Asterisk non-termination, infinite loops circular definitions or missing base cases can lead to infinite loops. Carefully examine your recursive predicates and ensure they have proper termination conditions. Unexpected backtracking. Prolog's backtracking behavior can be surprising if you're not familiar with it. Use tracing to understand how Prolog is exploring the search tree. 8. General debugging advice. Start small. Don't try to debug a huge, complex program all at once. Break it down into smaller, manageable parts. Write unit tests. Create test cases for your predicates to verify their correctness. Document your code. Clear and concise comments can make debugging much easier. Don't guess. Use the debugger or print statements to get accurate information about what's happening in your program. Ask for help. If you're stuck, don't be afraid to ask for help from experienced Prolog programmers. By combining a solid understanding of Prolog's core concepts with effective debugging tools and techniques, you can overcome the challenges of Prolog debugging and write reliable and efficient Prolog programs. Good luck.